Performance testing, load testing, resilience testing. In 2025, having these non-functional testing skills isn't just a nice to have, it's essential. As data volumes grow and system sizes expand beyond imagination, the demand for high-performing resilient software is higher than ever. Learning non-functional testing in 2025 is one of the best career moves that you can make. Hi, I'm Rohit Singh, and over the past decade, I have run non-functional testing initiatives at companies like SopraSteria, VMware, and Broadcom. Today, I run my own business, which is called Populosoft, and we specialize in iOS development and quality assurance as a service. Today, I'm launching a new video series where I will share practical insights and lessons that I have learned over the years. If you are a tester, developer, or just someone who wants to build a better software, hit that subscribe button so you don't miss a thing. Alright, let's jump right in.
Welcome to this lecture where we are gonna discuss mainly non-functional testing and how to do it. Lots of stuff about mainly performance and resilience testing. I will try to share what I learned from my experience. Let's get started. These are the things that I plan to discuss today. What this training will cover, just to discuss in general what we are gonna try to cover in the next 9 or 10 lectures. Why do we need such tests? What was the need? Why do we need performance and resilience testing at all? Some of the terms that we use, probably they will be a bit simpler for you, and maybe you know some of them, but still just to discuss them for somebody who is not aware of that. We'll try to classify the tests. So this classification will be basically how I see it. It's no industry standard. Pretty much for the whole lecture, some of the knowledge will be what I have learned so far, and maybe it's not completely a standard practice in the industry, but still I would try to show how I divide things and how I try to remember them. Today I will discuss some real world lectures, real world examples of failures. So some problems that we found during such tests and what were their resolutions, how were they interesting, just to show you what value this kind of test can bring. And maybe some skills just to give you an idea what I think you could get and try to improve so that you could be a better non-functional tester. This is what I will try to share today. And I think this is going to be it today, not a lot of detailed technical task or something like that, just some discussions and to get you started on this topic. So about me, how I learned all of this. I've been working as a non-functional tester, and like most of my experience, probably 80 or 90% of it has been building solutions for non-functional testing. And by non-functional, I mean performance and resilience type of tests. I have worked with, I haven't done smaller projects. Most of my projects were longer in length, like a couple of years or 1.5 years, something like that. And where we tried to take a complete system and try to build a testing solution, finding some issues along, helping the product team to improve their performance and resilience abilities. And so yeah, that's how I learned it. Again, in my current project as well, I am responsible for breaking down the current performance testing solution and suggesting optimizations wherever possible. And it's an e-commerce website, which is it's not like a website. We actually support e-commerce by providing some capabilities, for example, navigation and search. And each query that comes to us, we have to return the response under 200 milliseconds, or we have different SLAs with different clients, or let's say different businesses, but SLAs are important. So if the response times are not as fast as they should be, also if there are failing queries, it's a big impact on the business. And another thing is that such type of problems are really hard to fix in the end. So once you have designed a system and your system is up and running, um, and you at the end when you see that the response times are not what you were looking for, there are failures, the nodes are not scaling up and down as much as you would like. If you are in the last phase of the project, it's probably already too late. So it's really good practice, and it's recommended to build such practice as a culture. And what I mean is that you should start thinking about non-functional aspects as fast as possible, pretty much when you begin a new project, because hardly any projects, applications, websites, they serve just a couple of users. All of them are supposed to scale up, and all of them are supposed to uh, provide services to hundreds, thousands, or hundreds of thousands of users or services. So yeah, it's critical these days. And as the way I see it, our reliance on technology is only increasing. So the number of devices and users that we have today, it's only gonna increase exponentially. There is no going back. So there is uh, no time when there will be no demand for performance test engineers. It's only going to increase, and it's actually an yeah. I will talk about these things later, but it's critical, and it's only going to get more and more critical. That's my point. So let's go into more details. Uh, so this is what I was talking about. What we will cover during the next 9 lectures. I think we have 9 more after today. So why do we need such tests at different points of different lectures? I will show you a use case or something like that where we needed to do such tests and how they actually brought value. We will talk about concepts of performance testing during the whole lecture, as well as some of them, like quite a lot of them will be today. These concepts are important to have a separate view of everything in your brain. So sometimes we have knowledge, but it's not organized enough, and that's why we cannot pull out the ideas when we need them. So what we need to do is to organize it a little bit in our brain. Classify things. So, for example, if I need from topic one, subtopic one, a kind of test, or what kind of test I actually need. So, we'll try to make all of this non-functional testing look a little bit organized. We'll try to design small chunks of projects, nothing really huge, just some smaller practices where we will try to do performance and resilience type of testing, and maybe just a few lines of code just to demonstrate how there could be a leak. um, if there is a leak, how you can monitor it, what is a leak exactly, what kind of test you need to uncover leaks. So yeah, just some examples. Not today. Today I'll just mainly talk about concepts. So, and the last one is in this process, we usually have some inputs and outputs. And by that, I mean we need to get requirements, and we need to deliver a result, and we actually need to deliver it so that it's heard and it's not just ignored. So if you find something interesting, it's also your responsibility to communicate it to the right people and make an impact with that knowledge, with that finding. Because if you keep it to yourself or you don't communicate clearly, your findings might be critical, but they might not be noticed by the right people and might not be worked upon. So this is more or less a very high level description of what we are going to try to do in this training. Of course, there will be more topics, but in one slide, that's how I could how I could summarize stuff. Uh, Moving ahead, so what is the need for performance testing? Um, this is like a really big topic, and I'm sure you have seen yourself quite a few cases where there were outages, where there were problems. But here is something I try to summarize in my own words. And so if you look at if where we are sitting, if you just look around, I see about five three or four or five devices with me, like a tablet, a phone, a laptop, another phone, and it's like each of them have tons of sensors, tons of inputs and output points. So a phone these days has so much data it collects that if it's slow and if it doesn't perform up to speed, it will just choke up and die at some point. So um, same thing for so pretty much the devices and the users are increasing exponentially, and endpoints like if you talk about how different services are built, each service has to talk to some other service. They need to talk via endpoints, and uh, lots of things are getting deployed in the cloud. But if you, I mean, in general, things are exponentially increasing. And if I look at 10 years from now, you probably heard already how data is doubling or tripling every year. The devices are probably going at the same rate, and the users. So each e-commerce company has its own website. Um, so even like just name one company, and you will see that it's either already has a website or it's planning to launch it. And it because everybody needs to go out there in the digital space and start using it. But what happens with such huge increase is that there is expectations on the core services that they will keep up. So when a sale goes live, um, it's not acceptable if your website goes down for the first 20 minutes, 30 minutes. It loses tons of money. I was just reading on the internet some examples about it, and there is actually like unlimited examples, but some big websites they lose millions of dollars or millions of whatever every minute or 2 minutes. They are such huge websites. And another thing that they lose is reputation. So for example, recently YouTube went down, and the people who are usually engaged in watching YouTube, what they do in their free time is actually they go to social media sites and post messages that YouTube is down. This is unacceptable from Google, and so pretty much it's a double it's a double loss. First, they are losing revenue because YouTube is down, and then all those users are actually talking and bringing down the reputation of a company. And if it happens few times in a row, I'm pretty sure that the business will feel the impact much heavily. And it's not just any site, anything. If you go to a website frequently and you start seeing that it's down, you will probably find an alternative to it. Also, if you go to a website or a service and you usually find it slow, you like there is so many studies that if a website doesn't return result in that many milliseconds and you can't go to the next page, user starts to look for another option, and you pretty much lose a user at that point. So um, if it's not fast, if it's not highly available, which I may point it out here, high availability is not optional anymore. So for example, there is a software or yeah, let's say we are in an airplane, and the software obviously is critical. Even if the engines, like one of the engine goes down, there is a backup. But what if your system or the system controlling the airplane, the computers, they start going down? Do you have backup for them? Were they designed the same way the engines are, like to have a couple of them or four of them? Also, if one fails, does the second one can it take the load? Those kind of things need to be answered while the plane is on the ground. I mean, when the project is started, and not when the plane is already flying and you are trying to test in the production. So obviously, you need a good solution to test such things. You need to replicate as much client and business scenarios as possible. And this makes this whole performance testing and resilience testing a high demand skill. And another interesting thing about it is that there is not enough engineers in this field, because I've seen companies trying to look for such positions for a very long time, and they don't find the right candidate. It's because this is a little bit expensive, or let's say quite expensive process. First, you need expensive engineers, and then you need expensive equipment to do that. And sometimes the issues can go on for a couple of days, months, couple of weeks, months, really long time, and that's a big investment that sometimes companies don't make. So the skill is limited, both in the testing world as well as in the development world. So people who can uh, build such solutions, or people who can help in fixing the actual system for such issues, are a bit hard to find. So it's definitely something interesting to learn and to grow in if you are interested. Um, so let's talk about some of the terms which we are gonna use. I speak them very often when I talk about these topics. So I'm gonna quickly. These are like really few, but I found that I use them quite a lot. So what is throughput? Um, so every system has to process either some transactions or some requests, or in terms transactions, and yeah, pretty much we can call them transactions. So throughput would be the amount of the number of transactions or the number of requests a system can process in a unit of time. That unit could be dependent upon you. So if it's a second, you want to see how much the system can process every second, or every minute, or every hour. It's up to you, but basically means how much you can process. Um, what is a load model? Load model is uh, the way you apply, the way you send requests to a server. So you could send those transactions, like thousands of them. Like you could send a fixed number of transactions to the server, or request to the server every minute. So you send, for example, 1000 requests to the server, and every minute you just notice the response times from the request. So how much is the response time? Another way to send the request to the server is as fast as possible. So pretty much you send the request as fast as you can. So in this case, either it will be determined by the server itself or your test client. So if your server can take more requests and your client is not able to provide them, then your client could end up being the bottleneck. And bottleneck is another term I put here, but I'll get to it. In the on the server side, it could be again it could be uh, it could also be a bottleneck. Your client is going fast enough, but the server is not able to respond. Okay, so that's the load model. It's like a, usually it could be visualized in a graph. So if I show you, like here, so this may be the first axis and this may be the time. This could be the axis on the left is actually the amount of load that we apply, and this is time. And a load model is your imagination of how things could go. So it could go like this. You first have a higher load, then up and down, but I mean, nobody does it like this. Usually we have something consistent. For example, the first case I talked about is it's consistent. You have the same amount of transactions per second during the whole entire duration of the test. If you increase it to like this, then it's another use case. The best load model is the one that can replicate what the client can do, in my opinion. So um, usually it's a good practice that I try to follow to replicate everything that's going to happen on the client side, and try to avoid something artificial, because maybe you will find an issue, but probably it's not the highest priority as the one which is actually going to happen on the client side. So for example, if a client has a peak during the evening and it goes like this, you start from 10 transactions per second, and at 8 p.m. in the evening it goes to 20, and in the like until the morning it drops down again to 5. Then try to replicate something like this, because if you find an issue with this, it will be the most relevant and most highest priority issue that we actually cannot handle what the client is trying to do to scale up and down. uh, Issue could be anywhere, not just when the throughput is highest. So what I mean by that is, in big systems, scaling down is pretty much also very important. So if you have automatic scaling in a system, if you have 10 nodes and then it's automatically scaling down as well. Then by the morning it should go down to 5 or 2, and it should free up some resources. Otherwise, it's cost becomes a factor. Anyways, that's how I visualize uh, the load model. But getting back to response times, it's the amount of time it takes for the request to get back. um, I draw a diagram. This is like a typical or a general system that I draw, and I will try to give some examples based on this diagram. In this diagram, we have a testing solution, which is pretty much what we build for testing the system, and on the right hand side is the actual system that we are trying to test. Um, in this scenario, we are doing end-to-end performance testing. Sometimes we might need to do different modules as well, but in my experience, end-to-end is the most important one and the common one, where we run what the system is gonna go through in the live setup, and we try to we monitor pretty much everything. So in this setup, you will see we have a test executor which generates load. We might have more than one test executor because sometimes we need to generate tons of users, tons of load. Uh, this is a server's node. This is a system's first node. This is a second node, and they could scale up and down. So we could have a third node and fourth node and things like that. Um, some of the things usually in a system, sometimes those nodes are connected to a common systems. For example, it could be connected to a common database where all the nodes fetch the data and put the data. They could be connected to a shared file system. So if your file system becomes slow, then it's a problem, because no matter how many nodes you scale up and down, the problem is in the file system. So because all of the nodes use file system, so it's a simple example. There could be much more complicated systems where you have authentication systems. All of the nodes use a single authentication system, and usually authentication systems are also really slow. I mean, if they are not built properly. I mean, of course, there could be some fast ones, but in my experience, we found several issues with that. um, this is to get more value. You usually use some kind of an automation server which talks to an automation slave, which can bring up and down these executors whenever you need them, which controls them, and which can from these test executors we get the test results. So when you send some request to the nodes, you get back some request, and that response time is noted on the test executor. um, that test executor, all of the data that we collect, we can safely save into a database of our own. So in the past, I have used some databases to actually save all of that data. You could simply save it in simple files like CSV files, and try to analyze it later. What were the response times? But like once you are in an advanced stage, you should always try to create a system which, like, there could be some properties of the system, like for example, whenever we have all the data collected, it should be visible for everyone to see it, and if it could be in the real time, then it's perfect. um, I will give you an example in the later lectures how we could build like a real-time test result management system, and how we are doing it currently. So as we can see exactly everything as it is happening while the test is running, which is perfect. Also, all of this should be tried to be automated from A to Z. I mean, from provisioning of the test executor to running of the test to reporting of the results. Of course, the monitoring system should also be automatic. You shouldn't have many manual steps. For example, if you have in the end of the test, you have a step to copy data from here to here, which is manual, it's gonna slow you down exponentially. Your automation is not completely automatic, and it's a problem. Finally, the monitoring system, which is getting data from all of these nodes, file system, database, just to see if the resource utilization on these systems is fine. If you have applications like you have a Java application, then you need to attach the JVM if possible, with some low overhead and not too much overhead, and send the data to the monitoring system. So this is the system that I was talking about, and I brought it up because we are talking about some of the terms. Uh, we are talking about response time. So when the test executor sends a request to the node, and then if the node responds back with the test executor, the total amount of time taken for the round trip, we can call it response time from A to Z and A to B and B to A. Um, these kind of things could be monitored. The next one is high availability, and then we have baseline. So high availability is a term that means a system like out of X period of time or an amount of hours, an amount of minutes, how much time the system was operating and functional in percentage. Usually we talk about it in percentage. So uh, you probably have heard about 99% availability, 99.99% availability. These are kind of the numbers that the companies aim for. So this service should be available 365 days a year, maybe with a downtime of 5 minutes, 10 minutes, or if possible, like no downtime forever. But usually there is always downtime, no matter how well you build your services, because YouTube goes down and everything goes down at some point. So that's high availability. Things available most of the time. The baseline is probably not in the diagram, best to explain. It's like when you run a benchmark test or a performance test, you note down the results, what were the average response times, or what was the average throughput that the server could give us, and then then you could change one thing in the system. It could be the product version, it could be the size of the server. You could change pretty much just one thing in the system. It's also recommended to change just one thing at a time, so that um, you easily figure out the issues. And the first numbers that you actually used for comparison, they are called baseline, the base numbers. What is latency? It's pretty much the amount of time that we lose. So latency could be anywhere in the system. For example, one time we did analysis of what's the latency, and if we increase the latency between these two nodes actually, or we increase the amount of round trip time between node and file system or node and database, how the system is going to behave. It's pretty much if the node wants to access something in the database, how much time is lost in the communication between this. And if it's these are some really good tests, because sometimes what we have is things go into, like in this case I have not put a communication, but sometimes nodes have to talk to each other just to get their health or something like that. It could be a design in the system, depends on, and maybe a set of nodes in one availability zone, and the second set of node is in another availability zone. By availability zone I mean different parts of the infrastructures. For example, they are separated by cities or separate by countries, and it could be a really good test if your different parts of system are separated, how it's gonna behave. Is the system still gonna handle everything properly? Uh, what else? Metrics. Metrics is a set of numbers, the best way I can describe it, that we usually monitor or we use to analyze our results. So metric could be anything from the amount of CPU used per minute, or the amount of memory used, or it could also be simply some product terminology metric. For example, that one type of request that were monitored, uh, pretty much a single type of monitoring thing that we can use in our tests. I would describe it as a metric. What's a leak? Leak is when you run some tests, or when the applications go into production or something like that. There are it could use some resources that it never frees up, and that resource could be memory. That resource could be a file system handler. That resource could be pretty much anything that is limited in capacity. So if we are making some connections and there are only limited amount of connections remaining, then we should free them up after each request. And if there is something that's not freed up, it's eventually going to fail the system, or cause some problems at least. and that's classified as a leak. What's a bottleneck? It's from the term bottle and its neck. So no matter how big the bottle is, if you try to um, get the contents out of the bottle, they can only come out at a pace how thick the neck of the bottle is. So if you have like a really big bottle with a really thick neck, you will always find yourself going slow because the neck is not thick enough, and it's a term used quite often in our discussions, that there is a bottleneck in this system. So if this file system gets slow, we will say that it's a bottleneck, or it's kind of very commonly used term. So it's good to know. If database becomes slow, then it becomes a bottleneck because nodes can go faster, file system can go faster, but the database is giving up. So it's kind of the neck of the bottle, and if we need to work on this to make the whole system go faster. Uh, more terms we'll see as we discuss them, as it's quite a few of them, and also you can ask me at the end of every lecture if I used some term which is kind of alien to you, then please let me know. Uh, how do we classify? That's a little bit in my mind. It's not again an industry standard. So um, when some requests come to you, you sometimes have to explain to the users um, what kind of tests you are going to build, under which category it falls, what kind of things you're going to monitor. Uh, and you pretty much have to explain the concept to them so they understand, as well as you definitely have to know the concept yourself. And that's when something like this can be useful to you. This is how I visualize it, but it's not an industry standard. You can also add or remove something from here from your experience later on. But from my experience, I was able to answer most of the requests for non-functional testing by discussing one of these topics. I mean, one of these tests is gonna ultimately help you achieve your goals. So yeah, we have two types: performance and resilience. I will talk. Let me actually talk about performance and resilience right now. So it's kind of another performance and resilience are different in one very big way. Here we always go for how fast things are going for us, how fast the server can respond. Um, is it slow and fast? So most of the questions will be answered in terms of the speed or the processing power of the system, or anything that we are trying to test. In resilience, we are gonna talk mainly about failures and problems. So if you want to break the system, I mean, before production, then these kind of tests will be useful because ultimately the system is gonna break at some point. It's always good if you can break it before production, so or before the real use case. And in resilience, we actually try to break and bring it back from the dead. So it's not just about breaking the system. If, for example, a couple of nodes die or one availability zone is dead, can you bring it up to the same level without interrupting services? Or if you are interrupting them, then you need to interrupt them for as little as possible. Also, in terms of failures, it shouldn't. We need to keep imagining new ways to make sure that the user is not impacted. I mean, if one of the node goes down or the database goes down, we shouldn't have. With the database, probably we should have problems, but um, there shouldn't be repeated transactions, copied the same transaction multiple times, or missing transactions. So user sends some transactions and there is no record of it anywhere, which is really strange thing. Um, these kind of things. So yeah, performance and resilience. And let me talk about them one by one a little bit more. So what performance testing covers is, as I mentioned, the speed, the how fast things can go. Um, and how fast they should be going based on the SLAs or whatever agreements you have with the customer. And um, we can classify them, or at least I classify them like this. So sometimes, or most of the times, we begin with benchmarks. Benchmarks are something like a measure of how fast the system will go if we repeat the request that that usually the client sends. I classify them in two more parts, which is focused and comprehensive. So, for example, your system can process four requests at four different protocols, or if it's a website, it can process 100 checkouts per second, but usually the checkouts don't come without the people navigating to it. But still, if you want to build a test for the checkouts, you can just somehow get to the step of checkout directly on the website and try to do 100 checkouts per second. It will be focused benchmark because you are focusing on one type of request. You are just doing the checkouts. Comprehensive would be when you perform the whole user journey. For example, you click on the home page, then you click on the product, search for a product, or search and click, and those kind of things back and forth, and do it a little bit more randomly. Then you go to the checkout page, and the whole journey you repeat it with 1000 users. That will be a comprehensive test because you are comprehensively doing multiple type of requests. In another type of a system which works on, for example, is a file transfer system where you can send files via different protocols. For example, I worked with a system which was able to send on FTP, SFTP, HTTP, PSIT, and so many different kinds of protocols. So building some tests with just one protocol, just send and upload and download files on SSH, for example, and upload and download files on all of them together would be comprehensive benchmark. So these two have this one has a benefit that it's easier to debug, but it's a bit different. It's a bit far from the reality. So sometimes, or quite a few times, you will not catch issues like when the system has to process tens of different things at the same time. It might hit issues that it's never gonna hit when uh, sorry, I think I did say something wrong. When you are doing the same type of request, it's easier to debug, but you are not gonna get yeah, you are not gonna find the issue that you will find with multiple different types of requests in when you are trying to do the comprehensive benchmarks. So yeah, it's a bit more hard to debug, but again, if possible, try to do the comprehensive ones, because when you find an issue with this one, it's most likely that it will be reproducible and it will be there in the production when in the things go live. The next one is scalability test. Here again, the focus is on performance. We are not trying to break and bring the dead back. We just need to see if, for example, in the diagram that I showed to you, if I increase the number of nodes, these ones, and I make go from 2 to 3, or let's say I have just one in one use case and then I add a second one, then how much processing power is added to the system? Does it actually go 2 times the processing power, or does it like usually when you double the nodes or the processing systems, it doesn't become 2 times because there is overhead in syncing these servers and talking to file system and database. But even if you get a decent upgrade, it's not going to double for sure. But if you get close to double, that would also be really great. That means your other parts of the system which are common are not breaking it up. Also, the synchronization between these nodes is not very time consuming process. Those kind of things. So in scalability, we have two types: vertical and horizontal. So vertical scalability is when just a second. Horizontal is when we add the servers, because I always confuse between the two, but I know that concept. So if you add more nodes, that's horizontal scalability. For example, if this is a AWS EC2 instance and this is another AWS EC2 instance, and if you add more and more EC2 instances, that would be horizontal scalability, where you are trying to scale by adding more individual servers or individual processing nodes. Vertical scalability is when you add more processing power to this node. So you increase the CPU from 2 CPUs to 4 CPU. That would be vertical. And you increase the RAM from 4 gigs to 10 gigs. You increase things like that on then you are doing vertical. and both type of tests might be needed at different times to make sure that you can meet the SLAs, you can achieve what you're trying to achieve. Spike tests. So in this one, the only difference is the load model. So here, this more looks like a spike test to me. On the left, just point it, it's the, let's say, the load or the request per second, and here it is the time. So if you have a 30-minute test and you go for 10 minutes for, and you in the middle of the test, it's still not very spiky. So let me make more. It's like a spike now when you are going more than double of your load, or yeah, pretty much like when you have in the evenings lots of users, or when you have a sale live on a website, or when suddenly all the stores are closing and they are trying to upload all their data at the end of the day. It's a spike, and it's interesting to see how much what will be the performance of the system at those point of at that point of time. So um, we need to meet the SLAs at pretty much the whole time. In most of the cases, response time should still be lower here, and that's what we need to test in spikes. Again, not trying to break it or not trying to send it through the roof to see if things are breaking, but in a, let's say, in a controlled manner, increase the load and measure the performances, and don't still not trying to break it. Um, that's how I categorize them. Um, let's go to the resilience test. This is exactly how it looks like in the picture. Let's break stuff and see if things break. Are we still gonna do what is the right thing to be done? So if you are in an airplane and one of the engine goes down, the plane is supposed to keep flying and not pretty much not come down, because usually there are two engines. But you don't want to do it directly in the air. You want to do it when the plane somehow test it, when the, yeah, in simulators or things like that. Um, this is the resilience. What is an endurance test? When you run the endurance, or sometimes I used to call it longevity test, is when you put the system to longer tests. So usually benchmarks are half an hour, 15 minutes, 1 hour, depending upon how much you, uh, how like how repeatable, how much repeatability you want to build. But if you have a test which is going on for 2 days or 3 days, or depending upon um, your judgment, what will be the correct duration for your system, you can build a longer duration test. It doesn't necessarily need to go as fast as possible. It could go at a medium pace or double the usual load. And you have to observe, in this case, the leaks, and the response times are not so important here because you're already having benchmarks for that. Um, but yeah, again, if you feel if you are interested, feel free to observe the response times and how fast the system is during the time. But most critical thing is there any leaks after 3 days? Try to monitor the heap memory, or the memories that the system uses, and see if there is a something is consistently going up. Usually if it's going up and it's significant, then the system will fail after some time. In your analysis, try to look for the whole entire duration and not just the averages. So um, try to look what happened in the first hour of the test, first day and the second day and the third day. How many transactions were processed on the day one? How many transactions were processed on the day three? Is it slowing down? Things like that. It comes in endurance test. Idle test is similar to endurance. I mean, is related to endurance, but just opposite of endurance, where we don't perform anything on the system. Just leave it idle for some time and observe if the system scales down, if it's an automatically scaling system. Again, sometimes the systems are just hungry for transactions, and when they don't find it, they start behaving strangely. For example, I worked with an application where it was uh, uh, trying to pull a directory for new files, and once it didn't find the file, it still put some kind of a event in the queue that the processing was done, and in the end the queue was full anyways. and the system came down after some time, and we actually found that issue. Another good point to do the idle test is to see if the system scales down, of course. So the resources should be minimum if it's an automatically scaling system. Under stress test, we increase the load to the point where we think the system would break, and pretty much keep increasing it until the system breaks. This is for the analysis that actually when the system breaks, how it breaks, and you can actually report really nicely to to everyone that this is the breaking point of the system, and that gives you a little bit more confidence that okay, this is the breaking point. Then most probably, if I'm going at this pace, I'm still far from the breaking point, and usually we should be far from the breaking point. What is a failover test? If one node in your system fails, for example, here, if this node fails, this is kind of a user of the node, must be redirected to another node. Um, in this case, I have not put a load balancer here, but usually in the middle there is a load balancer. This test executor will send the request to the load balancer, and this will also send the request to the load balancer. In one of the node, if fails, then all the requests should be redirected to different nodes. The reason I didn't put a load balancer here, because most of the time load balancers are used third party, and they are not the things that we are trying to test. We are trying to test something that we built. So, but yeah, if you have a your own load balancer, then you should definitely send it to the load balancer and see how things are going to go. But pretty much whatever transactions are being processed by one node should be taken up by node 2 without any loss, repetition, or uh, corruption of the transactions. And again, if it's in your SLA that no matter if a couple of nodes goes down, the performance will be observed, then you should definitely also take a look at the performance. The last one is recovery. So all systems go down eventually, as you know. Any hardware will go down at some point. Any server that you use, if you leave it for tens of years, at some point it's gonna fail and crash. Or yeah, I mean that's kind of theory that I think about. But maybe in 10 years you will change your server. But anyways, if it goes down, how fast can it come back? So after that, you have to spin up another node. When it spins up, you have to check that the traffic is again systematically synchronously, or not the word, symmetrically distributed between them. Uh, when the node is coming up, if it some transactions are sent to the node, how what it does with those transactions. So uh, if I mean the node could come up in stages, and it shouldn't misfire some of the transactions just because it's coming up. It's these are tricky things to do, but at least you know where you are going in the right direction, and by the complexity of it, you can judge that you need to be very organized and careful in your approach when you are trying to build a solution like this, because if you don't have a way to check the transaction state, so when you build your first test, you definitely need a way um, to make sure that the transaction that you actually sent was processed properly. There are no duplicate transactions. You should have checks on the uh, for example, other side of the test. If you are sending things to database, it's always great to if you can somehow check in the database table if the right number of rows are created for each transaction, things like that. Those kind of checks are really critical when you build your test. Otherwise, in the end, you won't be able to see how many transactions were actually live. So again, try to be organized in the approach as much as possible. Otherwise, it's gonna get messy real quickly. Um, that's about how I visualize performance and resilience tests, and that's why the topic of the lecture is performance and resilience and not performance testing, because both of these things are really important. And Here I'm going to talk about some of the problems that I faced during my experience, and the way they brought value to the product, to the solution, basically. So yeah, bottleneck with authentication systems happened more than once in my career. So I was testing one solution which looked something like the example that I gave you here. We had also an authentication system. So I don't know, this one and all of the nodes, this one, they had to, whenever I send a transaction, they created a new session, and that session must be authenticated via this certificate and authority manager system. And all of them have to, for each request, you had to go and fetch the, pretty much log in here, and only then you are authorized to do a transaction on the system. And it was a bottleneck. After running some tests, we started realizing that when we monitored this system, it was not using a huge amount of CPU or RAM or anything. So for a long time, we thought it's fine. But there were just too many waits and serial calls here. So one after another, it had to go through tens of steps. It never used enough CPU because there were waits after different steps. And um, in later on, we realized this is a bottleneck. So what we did is we just replaced this with a third-party tool, which is available in the market. It was being developed by our team, but we just for checking out stuff, we replaced it with a third-party tool. Um, and we got really good performance, and it was more than double and triple the usual performance that we used to get. It was a big win. So later on, what we did, we implemented a short workaround to this, which was the user was not authenticating for each transaction it was sending, but it created a session for longer duration, for example, for 10 minutes and 15 minutes, just one session. And in those 15 minutes, it could send unlimited amount of transactions to node. And that way the system became much faster again. And finally, later on, we developed, improved the system. This one, which again did not have serial calls. And I mean, finally, a big win. I mean, the value that we are bringing to in the project was by how much we can process. And if we can double up the processing speed, it's pretty much adding double value. I don't know if it's right term, but yeah, I mean, at least adding a lot of value, I would say. So race conditions, I faced several race conditions. Race condition is something when you have one resource and lots of different things are trying to access it at the same time. So one race condition that I faced was with the file system. In what we were doing is actually creating files in a hierarchy. So first there is a base folder, root folder, then there is a folder after that with multiple different folders, and there is a limit in file system or in operating system, I think, that we cannot create a more than n number of files, n number of folders in a system. So and the name of the folder was randomly being chosen out of it was 2 characters, and it was randomly being chosen. And strangely enough, when there were lots and lots of users, both of all of them tried to create randomly the same folder by the same name, even though it's a big tool, but because under heavy load. So we used to have some failing transactions, and we debugged it for some time. But finally, yeah, the problem was found, and such kind of race conditions. Again, I had a problem with database as well. Um, there was asynchronous threads in these nodes which were trying to access the database, um, and the database was not. We had to lock a table in a database to be able to write it properly. But because they were asynchronous, they were going at a strange times and locking the table while the other one is trying to open the same table for writing. And we pretty much had our tests were actually giving very inconsistent results. So if you repeat it for 30 minutes now, and if you repeat it tomorrow, then there is a big difference of 10% in response times, and we debugged it. So these kind of race conditions can be found, and the same thing for the users. I'm pretty sure when the users are using the system, if there is race conditions in different parts of the system, then it behaves very erratically. Sometimes it is fine, sometimes it's not. So later on, there was a queue created on this part of the system, and all the nodes sent to that queue, and that then there was some threads which synchronously took things from there and put it into database, eliminating the problem. Uh, endurance test was also a big success several times. So when there was an application for which we the first test that we built, usually we don't do that, is the endurance test. We built a script and we ran it for 3 days. We just kind of a workshop, and we started running the endurance test after the, like, on the fifth or sixth day of the workshop, and on the seventh day the whole system crashed, which was like a big notice from everybody. And after that we decided to build the whole non-functional testing for it, because if you have an application that crashes after a day, it's even more dangerous than the application that crashes while you are installing it, because after a day or two, your users are already pretty much deep, and then suddenly everything crashes, and it's pretty dangerous. The reason was it was using file handlers, and after on Linux there is limited amount of file handlers, and they were not closing them. So after a few days, the whole application was undeployed from the application server. The application server pretty much deleted the application or undeployed it because the application was behaving erratically, something like that. Very recently, we again, in the recent project, there were several times when we had failing queries, um, which after simpler Java upgrades, library upgrades, and that led to some hotfix releases, after which we had to pretty much rush some fixes to production, kind of a new release, because if there are failing queries, it's a big problem for us currently in the current project. That's about it. I can several more examples that I can probably provide to you later during some of the lectures. But that's how useful it can be to do such kind of tests and to build such a solution. Um, I'm sure you are thinking about some of the things that you have noticed about non-functional testing. So um, let's discuss at the end of the lecture. If you face some things, also some feedback would be great. So just gonna finish the last topic, and then we can go to some discussions, quick ones hopefully. I put together, from my understanding, some of the things that you can try to improve if you are trying to do some of the performance testing or such kind of activities. From my experience, I think performance testing involves a lot of diverse experience. So you could be doing one day writing some code for loading the server. Sometimes you need to design custom test executors, these kind of things. The next day you could be debugging a network issue. Next day you could be debugging a latency problem. Very next day you might be tuning the server for some up. You might be changing the amount of Java available or those kind of things. So it's very diverse, the things that you're gonna need. You could be fixing deep. Sometimes you could just have to go yourself if you have an idea in the system, what could be wrong, and try to fix that as well. In one of the project, I actually started debugging. I was to the level that I started helping in going into the system. Usually my responsibilities were testing, but again it was positive for the team. Um, who's Anybody who is able to who is ready to tackle a diverse set of tasks, and but still have an overall clear understanding of where we are trying to go, I think he's a good fit. And pretty much anybody can ramp up in this direction if they have the motivation. So, and also in this training we will try to give you some some ideas, thoughts, and some organization of how you can proceed, to give you a speed up in this direction. Some more things I wrote, like, try to improve. If you are not unorganized, probably it will be a big problem. And by organized, I mean you should have a clear design of things in your mind, and from today to the last day where you want to go, what kind of solution will you end up. Because in a few months, usually what happens is you lose focus, and you have several things going on. You're not in the right direction. Some of the tasks are from the previous uh, testing exercise are pending, then you get some new tasks and it becomes a mix up. Try to be organized as possible. Definitely good communication helps here, because sometimes it's really tricky to convince the stakeholders that this performance problem is gonna cause you lots of money, and it does cost you lots of money or lots of troubles in future. But if you don't communicate it properly, all your effort to find that problem would be wasted. So, and also patience, because another thing I needed quite a lot in this time was, you have a 3-day test running. How do you manage your time during that 3-day test? What do you do? So you pick up something else, and then do you monitor it? Do you not monitor it? How often do you need to monitor it? Patience is pretty much all the time needed here. So good if you can improve that, or if you already have that, it's perfect. um, I think in technical skills, I have seen people start from very beginning. I myself started as a fresher, but yeah, any general IT experience will help you here. Like if you know how the systems work, what goes on in the background, it will help you. Knowledge of architecture. So it's always good if you have a good eye for understanding the architectures of the system, and if you know where the problem could be, because when the problem starts in like a big system, you need to be able to imagine in which part of the system the problem might be, so you can start focusing on the problems. And generally, yeah, debugging skills and those kind of things in the job description you will always find. But uh, Definitely you need interest in the area. If you have deep interest, if you think this is really important, I think it's going to help you definitely give your best. And the last point is focus on the result. So sometimes people will test for performance and resilience because they were told to do so, which happens, like build some performance test. But if you can still keep the focus on the result, I mean, what kind of value am I going to add with a new test? It will help you. So uh, each performance test should answer a question that was asked by a client or a product manager. So if you are building a endurance test, the question that you might be answering is that, will the system be able to perform to do the to perform in the outside world 3 days in a row? If that's a question coming from the product team, then you need to build an endurance test, not a benchmark or not something else. Um, so each thing should answer a question, and don't like, another thing I found is that sometimes people try to learn lots and lots of tools with performance, and hardly they ever use them, because in my 6 years of experience I have probably used just a couple of them. And most of the time we had to build some custom solutions, because the projects are so different that you need to to pretty much build your own testing solution. Most of the time you can't really use a tool that easily. So learn some tools, but don't just go for them all the time. Try to improve your general skills and understanding of the system that you are trying to test, rather than learning more and more tools. And this is it. That's all I wanted to say. It was probably the lengthiest lecture for me so far. uh, Thank you guys. Thank you guys for waking up early and joining this. It's always good to share. Try this out, and yeah, definitely get in touch with us.